Determine the area of the polygon, then write an expression that can be used to determine the area. To break up this shape, a lot of times I see that people cut it here, and then they call that top piece a triangle, but you notice that doesn't come to a point. There's still a flat spot there. So instead, to cut it into a triangle, we would need to cut it here. Then we can either cut it across here and create a 1x5 rectangle, or we can cut it down and create two different sized rectangles. Okay, so I'm going to name these shapes 1, 2, and 3. So the area of the first piece, it's a rectangle, so we don't need the 1/2, and it is 1, 2, 3, 4, 5, 6, 7 tall, and 1, 2, 3, 4, 5, 6, 7, 8 wide. So this is an 8x7. And this is all for for rectangle 1. Number 1. Then for number 2 is 1, 2, 3, 4, 5 wide. And 1, 2, 3, 4, 5, 6, 7, 8 tall. And that is for the second rectangle. Then for the triangle piece, we need the 1/2. And it has a base of 1, 2, 3, 4, 5. And a height of 1, 2, 3, 4, 5. This is shape number 3. So that's our expression. And now to find the area, we're going to multiply each piece out. 8 times 7 is 56. 5 times 8 is 40. And then 5 times 5 is 25. And half of that is 12.5. So if we add all of those pieces together, these two make 96. And then that would give us 108.5 units squared. Number 4 says, if the length of each square is worth 2 instead of 1, how would the area change? Well, instead of being 8, now it would be 16, and instead of being 7, it would now be 14. So the area would be multiplied by 2 for the horizontal, and multiplied by 2 for the vertical. Which essentially means the area is 4 times as big, because we have to multiply by 2 twice. Number 5 says, determine the area, then write an expression to represent the area. So we might cut this one here. You could also cut it horizontally and create a 2 tall rectangle. Looking at this one, I might cut it here, and then I might cut it here, and maybe here and here. That would give me 1, 2, 3, 4, 5 rectangles. You might also cut it like this and create a rectangle there. And then cut it here and here. This one corner just creates a little bit of a funky shape. Maybe you cut it there and there. Either way, you could still get the same answer. You just want to be careful to make sure you find the correct area of each piece. So I'm going to name this one 1, 2, 3, 4, and 5. They're all rectangles, so we don't need any 1/2. This is 2 by 4 for that first piece. The second piece is 5 by 5. The third is 1 by 1, 2, 3, 4, 5, 6, 7, 8, 9. The fourth is 1, 2, 3, 4, 5 wide. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tall. And that last rectangle is 2 by 1, 2, 3, 4. So now we need to find the area of each piece. 2 times 4 is 8. 5 times 5 is 25. 1 times 9 is 9. 5 times 10 is 50. 2 times 4 is 8. Okay. Well, 25 and 50 make 75. 8 and 8 make 16. And then we still have the 9. 16 and 9 make 25. And 25 and 75 make 100 units squared. Question 6 says, describe another method you could use to find the area of the polygon from problem 5. Then state how the expression for the area would be different. Well, we talked earlier that you could find the area of the outside shape and then remove the pieces you don't want. So find the area surrounding the shape. And the way that this one would be different is we could subtract instead of adding like we did up here. We would subtract the areas we did not want.